Hello, everyone. Today we're going to talk about what are called histograms. So a histogram is a graph consisting of bars equal width drawn adjacent to each other, unless there are gaps in the data. The horizontal scale represents classes of quantitative data, and the vertical scale represents frequencies. The height of the bars corresponds to frequency values. So we're going to take our tables we had like last class, and we're going to turn them into a graph. So some important uses are visually displays the shape of the distribution of the data. It shows the center of the data, shows the spread of the data, and it's very easy to see if there's an outlier, if there's a bar that's far away, not with the rest of the data. So a relative frequency histogram has the same shape of a histogram, but the vertical scale is going to use proportions or percentages. So it's like the relative frequency table that we saw. We can also make that into a histogram. All right. Let's look at some common distribution shapes. So these are all histograms here. And these are 4 things we're going to look for. The first one, top left corner, the green one, is what we always hope for. It's what we say is bell-shaped. And this is a normal distribution. Frequencies start low, hit the maximum in the middle, then go back to being low, and it's symmetric. That's called a normal distribution, or you could call it a bell-shaped distribution for now. The red histogram is what's called uniform distribution. Uniform means everything's the same, so all the bars should be about the same. They don't have to be perfect, they just have to be about the same. So as long as the frequencies are about the same, we can say it's uniform. And then we have skewed to the right, skewed to the left. So this is a little tricky remembering which way is which. Skewed to the right means everything is going to be on the left side of our histogram. All the bars should be focused on the left side. Skewed to the right means all the bars are on the right side. We'll talk more about that in just a second. So when graphed as a histogram, a normal distribution has a bell shape. Many statistical methods require the sample to be approximately normal. So when we do hypothesis testing later on, we're going to need that condition. We're going to need the data to be bell-shaped. When data has a uniform distribution, the different possible values occur with approximately the same frequency. So like I said, all the bars are about the same. They don't have to be exactly the same, just about the same. So distribution of data is called skewed if it's not symmetric. So it's going to extend more to one side. So we say data is skewed to the right or positively skewed if it has a longer right tail. So longer right tail. The tail is longer on the right. And then data is skewed to the left or negatively skewed if we have a longer left tail. So we can match them up here. So longer right tail and then longer left tail, which means the bars are on the other side. And a way to remember skewness is if you put your feet together, it should resemble your toes. So if it's skewed left, it resembles toes on the left of your foot. If it's skewed right, it resembles toes on your right foot. So the bigger bars are on for skewed left. We're looking at our left foot. Everything's on the right side, but the tail is longer on the left. So that's just a little trick to remember it. Right. So that's going to be it for histograms. I'm going to talk a little bit more about some other graphs in general in our next lesson. Have a great day, everyone, and I'll see you next time.